So today is just practice on lesson 7, which is identity. So identity means that whatever you have on the left side of an equal sign, that is going to be equal to the right side. Okay, that's all that is. So demonstrate that x plus 2 times x plus 2 is not the same as x squared plus 4. This is the most common mistake that a lot of people make. It's not. And the reason is because you have to do x times x, which is x squared, x times 2, which is 2x, 2 times x, which is 2x, and 2 times 2, which is 4. So you have x squared comes down, 2x plus 2x is 4x, comes down, and plus 4. So this is the correct answer, okay? Not this. This is not equal to x squared plus 4, okay? All right. Box method is another way, right? So I just give you an example. So you should definitely, if you prefer box method as opposed to FOIL, first, outer, inner, last, then use that. That's completely fine. Model problem number 1, verify if the following is correct. Okay, so we're going to go ahead and, since most people prefer the first, outer, inner, last, and not box, I'm going to do it the first, outer, inner, last way. 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. 2 times 3x is positive 6x, and 2 times negative 2 is negative 4. Okay, that allows us to, if you have a plus and a minus, these right here just cancel out. So your final answer is 9x squared minus 4, and it says verify if the following is correct. 9x squared minus 4 equals 9x squared minus 4. They are correct. Okay. All right. Model problem number 2. Rewrite the following in standard. So standard means that you're going to do something like this, like x to the third plus something x squared plus something x plus a number by itself. So that is standard, right? They go lower in terms of the exponents. So here we have x plus 3, x plus y cubed. That means that you're doing x plus y times itself 3 times. Okay, so how do you do a question like this, right? You start out by multiplying these. Just ignore the last one and multiply 2 of them. So x times x is x squared, x times y is xy, x times y again is another xy, and then you have y times y, which is y squared. Okay, so our first part of the problem, there's an imaginary 1 here, imaginary 1 here, so this is 2xy plus y squared. And then finally, we have to take that answer that we just got and we have to multiply it by x plus y. And how do we do that? By doing the same thing, right? This x squared times x is x to the third. X squared times y is x squared y. When you multiply the 2xy times x, that's going to be another 2x squared y. 2xy times y is going to be plus 2xy squared, okay, because there's two y's. And then the final thing we want to do is y squared times x is going to be xy squared. There's an imaginary 1 there. And y squared times y is going to be plus y to the third. And now you just combine like terms. So our final answer is going to be x to the third plus 3x squared y plus 3xy squared plus y to the third. So we multiplied it, and this is going to be our simplest form. It says rewrite the following in standard polynomial. There we go. Okay. And model problem number 3. So it says demonstrate if the following is an identity. So let's go ahead and do that. So this is going to be a to the third. A times negative ab is going to be negative a squared b. And then we multiply a times b squared. That's going to be positive ab squared. Okay. So now we did all the a's. We're going to do the same thing with the b's. So let me just go ahead and switch a different color here. So if I have b times a squared, that's going to be positive a squared b. b times negative ab is going to be negative ab squared, and b times b squared is going to be positive b to the third. Okay, so what happens here, right? Let's go ahead and grab some red, because positive ab squared, negative ab squared, they cancel out. Negative a squared b, positive a squared b, they also cancel out. So you're left with a to the third plus b to the third equals a to the third plus b to the third, right? It is an identity. So yes, it is an identity. We have to state it depending if they're the same or not. Okay, good. So go ahead and do the check for understanding yourself and do some delta math problems. Check your work.